Now let's look at another similar problem, permutations. So given a collection of different integers, we want to return all possible permutations. So this is similar to combinations. It's slightly different because here we are keeping all the items, but we want their order to be different. We want to systematically enumerate through all the ways of ordering things. So yeah, I guess I encourage you to try solve this problem yourself, because I think it's something that if you haven't done before, then it actually would take a bit of time to think through what should be the right way to do it. Here is our solution in Java using this decrease and conquer method. Well, basically just using recursion. So this is the outer part. So this slides does not contain details of the this generate function, the recursive function that does the job, but it have a variable to store the answers, and so it's initialized, and then we start calling generate, passing in this array of numbers, and we also passing in the number zeros. This indicates that we have considered the zero numbers so far. So basically the k will be we have fixed the first k numbers, and then the rest of them we have not considered yet. So this is the recursive function. We call it generate. So again, whenever we have a recursive function, we first write the base case. The base case for here is when k equals num.length. So then we have there's nothing more to consider. So at this point, we will just convert this nums array into a array list of integers. So actually, it's there's no very easy way to do that. There's no sort of easy one-line solution to do that. I think there's you can use some streaming thing in Java 8 to do it, but I don't really like those. So anyway, the logic should be straightforward. We're just creating a new array list of integer using this int array, and then we add that into the answer. Okay, so that's the base case. Now the rest of the function is considering the general case. So we first consider the case that we keep the case number in place, so we don't change the case number. So then these we just simply recursively call and do k plus 1. And after that, what we are doing is we will consider all number after the case number, and then we switch that with the case number, and then we do recursive recall. So here the logic I wrote is slightly more complicated than switching, but it saves some assignment. So yeah, so this is when I do it, I sort of always try to do this relatively unimportant optimization. But anyway, so because we'll be switching the case number with the other numbers again and again, so why store the case number here? And then we'll go through starting from k plus 1's number until the last one. So we want to switch, so we will assign y to nums I, and then we need to put that number into the case position. So once we've done that, the first switching is done. So we call generate, we call recursive recall, and k plus 1. And after this, we are supposed to switch again, but since we're going to overwrite nums k anyway, so all we need is just put the number back at nums. So I mean, if we're inside the loop, all we are doing, the next time we'll be overwriting nums k anyway. So there's no point in sort of do a full switch to put the number y back into nums k. So only when the whole loop is done, then we put this number y back at their right position. So that's the recursive call part. And this is a similar method. I think it's actually exactly the same method in C++. And I guess this is I guess one of the reasons now I prefer C++ to Java when doing competitive programming is you can do things like this, and there isn't the difference between a capital I integer and the lowercase I integer in Java, and you can do this adding this array into the solution. It can be done just in one line. And I want to mention that there are many other ways of doing this generating permutation. So here there's a tutorial on Topcoder talking about that. But I think it's important to know one way and to understand this the idea of using recursion to do this. But if you're interested, feel free to explore other methods.